Let's see kinetic energy and potential energy during simple harmonic motion. Let's take case 1. You know that in case 1 we say that x is a sine omega t. Means object starts from the mean position. It's oscillating and at t equals to 0, object is at the mean position. And it's moving towards the positive amplitude with initial velocity v, and you know this v is a omega, maximum velocity. When you are at the mean position, velocity is maximum. Mean position means x equals to 0. This is the amplitude, x equals to a omega. That's called case 1. If x is a sine omega t, then v is dx by dt. Let's say this is v naught for maximum velocity at this point. So what is v? Dx by dt, which is a omega cos omega t. Differentiation of sine cos omega outside. This a omega is v naught, maximum. This is v equals to v naught cos of omega t. We have got x, we have got v. And these are the two things which we need for kinetic energy and potential energy. What is kinetic energy? Kinetic energy is half m v square, which is half m square of this number, which is v naught square cos square omega t. Half of m times v naught square cos square omega t. This is your kinetic energy. Now, this kinetic energy part, which has cos square omega t, will convert this cos square omega t with the help of this formula. What is cos square theta? Cos square theta is 1 plus cos of 2 theta divided by 2. I hope you remember this. Cos square theta is 1 plus cos 2 theta divided by 2, and therefore this kinetic energy, it becomes half of m v naught square. What is cos square theta? 1 plus cos of 2 omega t divided by 2. We'll try to understand something special, and that special thing is, look at angular frequency of x, simple harmonic motion. It's omega. If angular frequency of simple harmonic motion is omega, you can see that kinetic energy part, its angular frequency is coming what? 2 omega. What does it mean? It means that if frequency of SHM is F, then frequency of kinetic energy is double of that. What basically it means, we'll understand that with the help of an example and a graphical approach. But let's first write down potential energy also. Now, what is potential energy? Potential energy for a force system of this type, F equals to minus kx. What is this? This is the fundamental equation of SHM. A equals to minus omega square x. F equals to minus kx. For a force system of this type, you know that potential energy is half of kx square, spring potential energy. F is minus kx. Potential energy is coming half of kx square. From this, you know that we get acceleration as force upon mass, which is minus of k by m, which we write minus of omega square x. So, for an acceleration system of this type, which represents simple harmonic motion, which is this force, restoring force, proportional to x, potential energy is given by half kx square. If it is half kx square, then what is x? A sine omega t, square of this part. Square of this part is giving you a square sine square omega t. Now what is this? This is half of k into a square. What is sine square theta? Just like cos square theta, we have sine square theta. What is sine square theta? 1 minus cos 2 theta divided by 2. That's how we write sine square theta in terms of 2 theta. So if we have sine square omega t, then it becomes what? It becomes 1 minus cos of, if this is theta, then double of it. That is 2 omega t whole divided by 2. This gives you what? Potential energy. Again, if angular frequency of SHM is omega, then you can see that frequency, angular frequency term for potential energy is coming what? 2 omega. What's the meaning of 2 omega? We'll see that, but first write down the statement. The statement which is coming from these two things. If frequency of SHM is F, if frequency of SHM is F, then frequency of kinetic energy and potential energy is 2F. Then frequency of kinetic energy and potential energy is 2F. Now, what is this 2F part? How come frequency is doubling when you move from simple harmonic motion to its kinetic and potential energy parts? Suppose during one oscillation, it starts from this position, t equals to 0, and completes at this position, which is given by capital T. Between the starting point and the end point, during one oscillation. Let's say we have a point here, and for this point, somebody says that x is coming plus 2. X is what? 2. Now, or to take it better presentation, we'll take it 3. So you'll be using 2 again. Let's say this position is x equals to 3. Now, how many times 3 repeats itself during one oscillation? If I ask you this, how many times x equals to 3 repeats itself during one oscillation? When object is here, x is what? 3. When it is coming back, remember, x is again what? 3 only. It's not minus 3. You are again on the right hand side. And therefore, for this position and for this position, x is what? 3. When you come here, somewhere here, your x coordinate, it will become what? Minus 3. But my question is, how many times x equals to 3 repeats itself during one oscillation? And you will say that it repeats itself 2 times. This and this. For both these positions, your x is what? 3. Whereas for both these positions, your x is what? Minus 3. Remember, it's just a straight line motion like this. straight line motion. Now, if you say x equals to 3, x equals to 3, it repeats itself 2 times during one oscillation for this position and for this position. And then I ask you how many times potential energy corresponding to x equals to 3 is going to repeat itself. Then look at the potential energy function, half k x square. Suppose we take k just for our understanding. Let's take value of k as 2. If k is 2, potential energy is what? 2 x square, 9. Over here, what is the potential energy? 9. At this place, what is the potential energy? 9. What is potential energy at this place? Again 9. Half k x square. What is potential energy at this place? Again 9. That means for this position, for this position, for this position, for this position, your potential energy is what? 9. And this 9 is repeating itself 4 times. 9 is repeating itself 4 times. That means if in SHM a given x repeats itself 2 times, then corresponding potential energy repeats itself 4 times. Which means if you say that frequency of SHM is f, if frequency of SHM is f, then frequency of potential energy function is what? 2f. That's what it means when you say potential energy and kinetic energy, the frequency is what? 2f. Now, this is one way of understanding how things repeat themselves again and again. Same argument you can use with V. Same thing. V is what? Square. If V is square, that means at this point, at this point, at this point, at this point, your velocity part is going to repeat itself 4 times. And therefore you will say that, not velocity part, kinetic energy part, it is going to repeat itself 4 times. Now, this whole thing can also be understood with the help of graphical approach. What is the graphical approach? If I say that, if I ask you to plot a graph of x and t, if you plot a graph of x and t, you know that this graph will be what? Sine graph, a sine omega t. How do you draw a graph of sine? That's how you draw a graph of sine. This is capital T, x versus t. But if I ask you to plot a graph of potential energy and t, if you plot a graph of P, potential energy, and T, what is potential energy? Potential energy is what? K x square. This time round, you're plotting a graph of sine square. How do you plot a graph of sine square? This is sine plus, this is sine minus. But when you go for sine square, this negative part and positive part, they both will become what? Same. And if they both become same, then your graph, it looks like this. Your graph, it looks like this. Now, can you see a special thing? Special thing is what? Look at this shape. This shape repeats itself once. The whole shape repeats itself once during time t. But over here, look at this shape is repeating itself twice. Which means what? If you say frequency of SHM is f, then frequency of potential energy is what? 2F. Or you can understand the whole thing in this form. If this is T, you know that this thing will be what? T by 2. So, corresponding to T, what is the frequency? 1 upon F. If you have time period which is T by 2, then you know that corresponding to T by 2 time period, your frequency therefore will be double of that, 2F. For T, frequency is F, T by 2, 2F, which is quite easily visible in this part. This argument is also present here. If you say that this place is x equals to 3, this is x equals to 3, this is also x equals to 3. So x equals to 3 repeats itself twice during one oscillation. But corresponding potential energy, which is 9, 9, 9, 9, it is repeating itself 4 times. It is repeating itself 4 times, and therefore your frequency becomes what? 2F. Remember this important statement. Now, the function which you see of potential energy and kinetic energy, if we restrict ourselves to this part only, then you will notice one thing. What is that special thing? What is this? P. Let's say you write potential energy as U. This is U. This is what? Half K A square sine square omega T. Now, the coefficient of sine part always gives you what? Its maximum. When your sine becomes maximum, which is 1, when this is 1, U will be maximum. This half K square is the maximum potential energy. So we can write this U as U naught sine square omega T. That's your maximum. What is maximum? Half Ka square. Similarly, look at this kinetic energy part. You know that maximum of cos is also what? 1. If maximum of cos is 1, that means this part which you see, half mv naught square, it will give you maximum kinetic energy, which you already know. What is V naught? V naught is A omega. What is A omega? Maximum velocity. So if this is maximum velocity, this coefficient of cos square, you know it gives you what? Maximum kinetic energy. Let's say we call it K naught. This is K naught cos square omega T. Capital K naught. What is capital K naught? Maximum kinetic energy. If I ask you that what is the relationship between K naught and U naught? What is K naught? Maximum kinetic energy. What is U naught? Maximum potential energy. If I ask you what is the relationship between these two, they are equal. This is larger, this is larger. Which one is correct? Then you will find that K naught is equal to what? U naught. This is also an important statement, that maximum kinetic energy is equal to what? Maximum potential energy. And how come these things are equal? We'll prove mathematically and then with the help of a simple experiment. So when you talk about kinetic energy, its maximum value is coming as what? K naught. What is K naught? Half mv naught square. What is K naught? Look here. Your K naught is coming half m v naught. What is v naught? A omega, and therefore this is a square omega square. That's the value of K naught. Now let's find out maximum potential energy, U naught. What is maximum potential energy? U naught. What is that? Half Ka square. Half K. What is K? Look here. K upon M is omega square. So what is K? M times omega square. K upon M is omega square, and therefore what is K? M times omega square. K is M times omega square multiplied by what? A square. Multiplied by what? A square. This, they both are what? Same. K naught is equal to U naught, and we'll now say that this K naught, which is equal to U naught, and the whole thing is equal to E naught. What is E naught? What is E naught? E naught is total energy during simple harmonic motion. Now come K naught. What is K naught? Maximum kinetic energy. What is U naught? Maximum potential energy. What is E naught? Total energy during simple harmonic motion. Now let's understand the whole part with the help of a spring block system. Remember, we have a block, it's connected to a spring and it's oscillating like this. If it is oscillating, when it passes from the mean position, when the whole thing passes from the mean position, at the mean position, you know that x is 0. If x is 0, there is no potential energy at the mean position. But at mean position, kinetic energy is what? Maximum. And what is total energy? Total energy during any event is what? Kinetic plus potential. So if somebody looks for total energy, if you look for total energy, you will write down what? Kinetic energy plus potential energy at any place, not necessarily mean position or amplitude position. Anywhere you will find that total energy is what? Kinetic plus potential. And this sum, you know that should remain constant because energy is what? Conserved. We are not changing the energy. If this total energy remains conserved, then when you are at the mean position, total energy is in the form of kinetic only. At mean position, x is 0, there is no potential energy. So, when you are at the mean position, this K is K naught. But what is U? 0. This is at the mean position. Then, when you reach amplitude, at the amplitude you know that velocity becomes 0. If velocity is 0, then your kinetic energy is what? 0. Kinetic is 0, but at the amplitude, that spring, it has maximum deformation. If it has maximum deformation, then your potential energy should be maximum, which is what? U naught. And therefore, you can see that we have again proved K naught is equal to U naught. And what do you mean by E naught? What is E naught? Total energy. What is total energy? K plus U. What is this equal to? This, which is what? K naught. What is this equal to? U naught. And therefore, we are also writing this whole part in the form of E naught, which you see over here. And therefore, your kinetic energy is K naught cos square omega t. If you wish, you can write it E naught cos square omega t. Your potential energy is coming U naught sin square omega t. If you wish, you can replace your U naught with what? Capital E naught. This is the graph of X and potential energy. If they ask you a graph of V and kinetic energy, things are exactly same. For V, you will be drawing a graph of cos. For kinetic energy, you will be drawing a graph of V square. How do you draw a graph of cos? Graph of cos starts from here. That's the graph of cos. It will start from here. If you shift your axis, vertical axis over here, you're looking at the graph of what? Cos. So things are exactly same as we have done with X and potential energy. Not a difficult task. You can do that kind of plotting yourself. Note down everything.